papers for paper 6, previously known as paper 7, which is probability and statistics 2, February March 2021, and the variant is only one, which is 62. It's a 50-mark paper, and the time allotted is 60 plus 15, which is 75 minutes. Let's read the first question. The question says, a construction company notes the time T days that it takes to build each house of a certain design. The result for a random sample of 60 such houses are summarized. Sigma T is given, sigma T square is given. First part, calculate a 98% confidence interval for the population mean, that is the first. Second part, explain why it was necessary to use CLT, central limit theorem, in part A. So I can comfortably write the answer of part B, that is CLT was necessary because the distribution was not normally distributed. It did not state that it had a normal distribution, and since sample was large, this is justification I'm giving. This is large sample, therefore it became converted into normal distribution. So the answer for this is, since the distribution was not normally distributed, that is why CLT was necessary. Now let's look at the first part, that is simple calculation. First of all, what we need is that we need unbiased estimates of population mean and unbiased estimate of population variance. So x bar, that is the sample mean, which is sigma x over n. But since we are using the symbol t over here, t bar is sigma t over n, which is 4820 divided by 60. Then what I do is that I calculate sample variance, which is sigma x square over n minus x bar square. So sample variance is s square for the variable t, that is sigma t square over n minus t bar square, which is 392050 divided by 60 minus 4820 over 60. Use the unrounded value. This is the sample variance, whatever this comes out to be. Therefore, unbiased estimate of population mean it's n over n minus 1 sample mean. So that is 60 over 59 into whatever this value is, and that's your answer. Of course, there is an alternative formula also. Let me take you to the formula booklet. So there is an alternative formula, and usually that's written in the mark scheme. Then why do I use this one? First of all, I find it easier to remember this. Secondly, sometimes they ask this question that relates this thing with this. So which one is bigger? So it's always that unbiased estimate of population mean will be bigger than sample mean. The reason being, n over n minus 1 will always be greater than 1. 60 over 59, 200 over 199. Giving you an example, that will always be greater. Now, if we go to the formula booklet, let me increase the brightness. And that's the formula booklet. And this is the formula that people can use. So 1 over n minus 1, sigma x square over this thing. So if you want to use this formula, that is perfectly fine. You get the same answer. It's just that the symbol that they have used is this. In reality, this is this thing. So that's your choice, what particular format you are more comfortable with. So you use this formula from the formula booklet, which is MF19. And what are we actually solving for? We are solving for 98% confidence interval. So now let's do that calculation for confidence interval. And let me just add some color in it. So therefore, our working is 98%, that is between two z values. This is 98%. There is 1% at the right, extreme right, 1% at the extreme left. So the z value is for 99%, which is, I think, 2.326. Let me double check it over here. So this is the 99% strip, and that is 2.326. This is the value that we get. So z value is 2.326. X bar value is 4820 divided by 60, whatever that comes out to be. And what else do we need? We have this unbiased estimate of population mean is given, and when you take the square root, this comes out to be 82.0904, and x bar, this comes out to be 80.3. And when you do the calculation, x bar plus minus z sigma over root n, so this is plus minus 2.326. Sigma is square root of 82.0904 divided by root n, which is root 60, and this is plus minus, and x bar is 80.3, or use the unrounded value. And then you end up with two answers, that is 77.6 and 83.1, correct to three significant figures. This is the 98% confidence interval for population mean. So that first question is done. That is confidence interval, and this is for population mean. Let's move to the next question. The next question we can see, this is about CRV. A diagram is given. They are asking for the value of k. They are asking for find fx, hence find expectation of x, and then some probability, some unknown constant is being asked based upon that. Very first thing, since it's a CRV, so wait a minute. Okay, now it's going to work. This is a CRV. Therefore, area under graph represents probability, total probability, which is 1. So this is k, this is half k. Therefore, for the first part, the area is half into k into half k equals to 1. And then when you do the working, so therefore this working is 1/4 k square equals to 1. Therefore, 4 is equals to k square. Therefore, k is plus minus 2, which is plus 2. So because we can see for ourselves, that is the positive value that they have taken. So the value of k is 2. Now, what else are they asking? Use this value of k, find fx. So now, this is 1, this is 2, and use coordinate geometry. The gradient is rise over run, which is negative half, it's coming down. The y-intercept is 1. The function, the equation of a line is mx plus c. That is this thing. It's going down. Yes, it is minus half x plus 1. And c is 1. And this function is valid for the interval x lies between 0 and k. So 0 is 0 and k is 2. They're asking for expectation of x. Expectation of x is x multiplied by the function between the limits, integrated between the limits a and b. So the limits are 0 and 2, x multiplied by negative half x plus 1 dx. That becomes negative half x square plus x. It's not yet integrated. This is simple multiplication. This is minus half. This is x cube over 3. And this is x square over 2 between the limits 0 and 2. And these small things I'm leaving for you to evaluate. So therefore, the expectation of x is done. Then it says find the value of find the value of p such that probability x between p and 1 equals 2.25. So therefore, lower limit is p, upper limit is 1. Integrate the function minus half x plus 1 dx equals to 0.25. So therefore, minus half x square over 2 plus x between the limits 1 and p and that should equal it to 0.25. So I'll just do a bit of calculation. So therefore this is minus 1/4 p square plus p minus 1/4 1 square plus 1 equals it to 0.25. You would simplify, you would get a quadratic equation. It could factorize, it could not factorize. Just focus on the formula, quadratic formula, and you will get the answer. So you will find the value of p. Make sure this answer is between 0 and 2. So make sure the answer is between 0 and 2. So any answer outside of range is rejected. Why? Because the function lies between 0 and 2. So this is CRV, this question is done. Question number 3. An architect wishes to investigate whether buildings in a certain city are higher on average than buildings in other cities. He takes a large random sample of buildings from the city, finds the mean height, he calculates the value of the test statistic z, and finds z is 2.41. Explain briefly whether he should use one-tailed test or two-tailed test. So the answer for this is use a one-tailed test, because you are just focusing on higher than others. So this is like alternative hypothesis will have a greater sign. So therefore, you should be focusing on one tail only. Therefore, it's a one-tailed test. Carry out the test at the 1% significance level. First of all, state the distribution as such. Now, the distribution is not given. The number of sample is not given. So basically, all I have to do is that, let me see if I have my normal distribution curve, which is here. So this is my normal distribution curve, and it's an upper tail test at the 1% level. So this is 1%. This z value is 2.326. This is 0. This is 2.41. So it lies inside the critical region. This is the calculated z value, 2.41. What is the conclusion? Reject H0, accept H1, except that the buildings are higher than other cities. So write some more words. You would say, yes, there is sufficient evidence. And whose idea was this? The architect. And that was his suspicion. So there is evidence, there is sufficient evidence that architects' guess or suspicion is correct. So that's how you write it. Question number 4. Now on the same page they have given another question. Let me highlight it. What is this question all about? 1 in 400 microchips from a certain factory are faulty. The number of faulty microchips in a random sample of 1000 is denoted by x. State the distribution of x. So this is a binomial question, and most probably it will be converted into a Poisson question. So you would say x follows a binomial distribution. 1000 is the number of trials. 1 over 400 is the probability of success. State an approximating distribution. N is 1000. P is 1 over 400. NP is 1000 into 1 over 400. And this comes out to be 2.5. And you would justify. Are they asking for justification? No, they are not, but it's better to justify. Since n is greater than or equal to 50 and np is less than 5, therefore x follows a Poisson distribution with 2.5. So now it's a Poisson scenario. Use this approximating distribution to find each of the following. So probability x is equals to 4, that is e raised to power of minus lambda. Lambda raised to power of 4 divided by 4 factorial, and then you would use your calculator and you would get the answer. Probability x lies between 2 and 4. So probability x is equals to 3. You can add it up. E raised to power of minus lambda and lambda raised to power of 3 over 3 factorial, and probability x is equals to 2, that is e raised to power of minus lambda, lambda raised to power of 2 over 2 factorial. And then you would add all these three things up, this and this and this. So you would add it up and that is your answer. Take care of the accuracy. Use a suitable approximating distribution to find the probability in a random sample of 700 microchips there will be at least one faulty one. So x follows a binomial distribution 700, 1 over 400. NP is 7 over 4, which is 1.75. And justify again, n is greater than 50 and NP is lesser than 5. So therefore x follows a Poisson distribution with 1.75. And then it says, what is it asking for? At least one. Probability x is greater than or equal to 1, which is 1 minus probability x is equals to 0, which is 1 minus e raised to power of minus 1.75, and that's the answer. So this question about binomial and Poisson approximation, question number 4, that is done. Question number 5. Question number 5 looks like linear combo, and this is linear combo of normal variables. There are two kinds of juice bottles. Large follows normal distribution 5.10, 0.0102, 0102. That's perfect. And small follows a normal distribution, that is 2.51, 0.0036. So let's hope it does the cut pasting correct. So this is copied and I'm moving to the other part. I don't know, there's some issue. Wait a minute. No, it's not. Large follows a normal distribution, small follows a normal distribution, such, 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 5.1 and 0.0102, 0.0102 and 5.10 and 5.10, and this is 2.51, 0036, 0036, and this is 2.51. Now it says, find the probability total volume of juice in 3 randomly large bottles. So let x equals to L1 plus L2 plus L3. Therefore, x follows a normal distribution 3 times 5.10 and 3 times 0.0102. Similarly, let y equals to S1 dot 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 all the way till S4. Y follows a normal distribution 4 times 2.51. So this is 4 multiplied by 2.51 and 4 multiplied with 0.0036. 00 or triple? Double. 0.0036. So now it says a total. So let W be the total, which is x plus y. So W follows a normal distribution. This thing will be added to this, and similarly this thing, pink over here, this thing will be added to this. So let me, okay. So therefore, when we do this calculation and after everything, what we get is that the mean is 25.34 and the variance is 0.045. So there is a huge difference between the mean and variance. Now it says less than 25.5. Probability W is less than 25.5. Probability Z is less than 25.5 minus 25.34 divided by 0.045 square root. And after you simplify, this is Z is less than 0.754. This is rule number 1 from normal distribution. So read the table for 0.754 and this comes out to be 0.775. The answer is rounded off correct to 3 significant figures. So From here onwards, this is your knowledge of S1 normal distribution. So now this thing is done. Our second part, find the probability the volume of juice in a randomly chosen large bottle is at least twice the volume. So 2S follows a normal distribution 2 times 2.51 and 2 squared times 0.0036. So that is the working for this one. So expectation, first of all, a large is greater than or equal to 2S. Large minus 2S is greater than or equal to 0. Let's call this as M. So M follows a normal distribution. The variances are subtracted. So the means are subtracted. So this is mean. This is mean. When this is subtracted, what you get is 0.08. So this is means are subtracted. But variances are added. Remember this rule. Also remember this rule of multiplying with square, because this is a concept of multiple. So now over here, what else is happening? That this thing and this whole thing is being added. So when this is added, this becomes 0.0246. 0.0246. This is what you get. Now it says, what are we calculating? We are calculating this. Probability M is greater than or equal to 0. Probability Z is greater than or equal to 0 minus 0.08 divided by square root of 0.0246, and then knowledge of S1 is assumed. What you get is that probability Z is greater than or equal to negative 0.510. Now what's the rule? Flip the inequality and remove negative sign. Probability Z is lesser than or equal to 0.510. That is direct reading phi of 0.510, and this comes out to be 0.695. That is the answer for this part. So this question was pretty straightforward, of linear combo. Question number 7. Question number 6. Question number 6, it says, this is about what? It is known that 8% of adults in a town own a Centaur car. After an advertising campaign, a car dealer wishes to investigate whether this proportion has increased. So now our focus is on increase. Our focus is on 8%. Random sample is of 25 adults. How many of them own a Centaur car? This 4 is the sample value. And carry out a hypothesis. That's the first part. Which of the errors, type 1, type 2, might have been made in this carrying out this test? Later, the dealer takes another random sample and then does the calculation, and let's see how things goes. So now, first of all, it's a question of hypothesis test. It's a question of type 1 and type 2 errors, and it's a question of binomial. So first of all, write it. X follows a binomial distribution 25,8%, that is 0.08. And what else is there? The sample value is 4. H0, our probability of success is 8%. H1, advertisement, the whole reason of giving that advertisement, the whole rationale was to increase the sales. Now you have to calculate in this direction, and this value is inclusive. So probability X is greater than or equal to 4, which is too much to calculate. 1 minus probability X is lesser than or equal to 3. So this is 1 minus 25C0 and 25C1 and 25C2. So therefore this thing is success is 8%, success is 8%, success is 8%, this is 92%, and so on. That is failure. and this 0 goes at the top, this 1 goes at the top, this 2 goes at the top. The difference is 25 and 24 and 23. Now over here it's between you and your calculator. And when you do the subtraction, I'm not going to take care of the accuracy. 1 minus 0.135. So this comes out to be 1 minus 0.865, which comes out to be 0.135. This is the answer that you achieve out of this. What is the significance level? So this is 5% significance level. What is the rule? If the probability value is lesser than significance level, then reject H0. So this is 13.5%. Is it lesser than 5% significance level? The answer is no. So therefore the conclusion is do not reject H0. In other words, accept H0. Things are as it is. So there is insufficient evidence. And what is the idea? Car dealer wishes to investigate, and that's an insufficient evidence to show or prove that the sales have increased. Okay, so now this thing is done for 5 marks. Now explain which of the errors have been made in carrying out the test. Now always remember, whenever we reject H0, a type 1 error will be made. Whenever we fail to reject H0, in other words accept H0, type 2 will be made. So since this is what we are dealing with right now in this scenario, so therefore a type 2 error might have been made. That is the logic that we use. Since H0 is not rejected, therefore type 2 error might have been made. Now it says later the car dealer takes another random sample of 25 adults, carries out a similar test, find the probability of type 1 error. Probability of type 1 error. This is by trial and error that you would calculate. So basically we already know that probability x is greater than or equal to 4 is 13.5%. That means if I calculate more probability, which is 1 minus probability x is less than or equal to 3. So if I calculate more probability, so therefore this value would decrease. So therefore probability x is greater than or equal to 5, which is 1 minus probability x is less than or equal to 4, which is 1 minus probability x is lesser than or equal to 3 plus probability x is equals to 4. Why should I do more calculation when I already have the answer for this particular part? So this particular part, the answer was this thing, 0.865. So let me write this thing as 0.865. And let me do this calculation. That is 25C4, and this is success raised to power of 4 and failure raised to power of 21. When I do this calculation, the overall answer gets reduced, and this comes out to be 0.0451. That means 4.51%. I think that's bullseye. 4.51% is lesser than 5%. Therefore reject H0, and this is the probability of type 1 error, because the logic is probability of type 1 error means reject H0 when H0 is true. So that is where H0 is rejected. And that completes February 2021 S2 paper. Stay tuned for more.